Hello students and viewers, this is ETETA from Morogoro, Tanzania. My name is teacher Ramadhani Kideghesho teaching chemistry. Welcome to the series of our lessons from ETETA TV. In this lesson, I will show you the correct way of answering the different questions of topic of bonding, formula and nomenclature from the past paper of Certificate of Secondary Education Examination of National Examination Council of Tanzania. By starting, I will start to answer the past paper from the CSEE Necta 2015. The question number 9. Question number 9A, Roman 1 says, what type of chemical bond is formed between fluorine atoms in a fluorine molecule? Question number 9A, Roman 2 says, name other types of chemical bond formed by fluorine with other elements. Give one example, or give an example of the compound in which a fluorine forms this type of bond. So this is the question number 9A. The question number 9B says, compound X has 24.24% carbon, 4.04% hydrogen, and 71.72% chlorine. Given that the vapor density of X is 49.25. The question says, Roman 1, calculate the molecular formula of the compound X. Roman 2 says, draw and name the displayed or open structural formula of the possible isomers from the molecular formula determined. So these are two questions from question number 9B. Now I will start to answer the question number 9A. The answer is, the type of bond formed between fluorine atoms in fluorine molecule is a covalent bond. This is because the fluorine molecules involves the nanometal. Fluorine is a nanometal, so the bond between nanometal is a covalent bond. So the answer for question number 9A, Roman 2, another type of bond formed by fluorine atom with other element is electrovalent bond. And the example of compound in which fluorine form this type of bond is magnesium fluoride. So magnesium fluoride is an example of compound in which fluorine form the electrovalent bond. So this is the answer for question number 9A. Now the answer for question number 9B, first let's read the question. The question says, compound X contains 24.24% carbon, 4.04% hydrogen, and 71.72% chlorine. Given that the vapor density of X is 49.5. The question says, calculate the molecular formula of the compound X. Also, draw and name the displayed or open structural formula for the possible isomers from the molecular formula determined. So this is the question number 9B. So the answer for this question, let's start with answer for question number 9B, Roman 1. So from the table here shows the procedures for finding the molecular formula. You can't find the molecular formula if you don't have the empirical formula. First of all, you have to find the empirical formula. So the way of finding the empirical formula is as shown here in this table. As you see here in the table, we have carbon here, we have hydrogen, and we have chlorine. So the first thing you need to have the percentage composition by mass, and from the question we have been given the percentage composition by mass. For carbon, the percentage composition by mass is 24.24. For hydrogen, is 4.04, and for chlorine is 71.72. Another thing you need to have is the relative atomic mass. And the relative atomic mass for carbon is 12, for hydrogen is 1, and for chlorine is 35. Now you have to divide the percentage composition by mass by relative atomic mass. So here you will take, for carbon, you will take 24.24 divided by 12, which is equal to 2.02. For hydrogen, you will take 4.04 divided by 1, which is equal to 4.04. And for chlorine, you will take 71.72 divided by 35.5, which is equal to 2.02. After getting the answer of this ratio, now you take the smallest ratio and divide it in all elements, or in the all ratio which you have been obtained here. So here the smallest ratio here is 2.02, because you have 2.02, 4.04, 2.02. So 2.02 is the smallest ratio. For that case, for carbon, you will take 2.02, then you divide by 2.02, which is equal to 1. For hydrogen, you will take 4.04 divided by 2.02, which is equal to 2. And for chlorine, you will take 2.02, then divide by 2.02, which is equal to 1. So this 1 to 1, which is obtained here, is going to help you to write the empirical formula. For that matter, the empirical formula for this compound is CH2 chlorine, as here in carbon is 1, hydrogen is 2, but the chlorine is 1. So it is CH2Cl. This is the empirical formula. Now, after obtaining the empirical formula, what's follow is to find the molecular formula. How to determine the molecular formula? The molecular formula can be determined by using the following formula. Molecular formula is equal to N times the empirical formula. Molecular formula is equal to N times the empirical formula. So here you have empirical formula, but N is unknown and the molecular formula is unknown. So what's follow, you have to find first the value of N. How could you find the value of N? The value of N can be determined by using the following formula. So the relative molecular mass is equal to N times empirical formula. From the question there, you have been given the relative molecular mass. And for that matter, you have been given the vapor pressure. So you have to find the relative molecular mass by using the vapor pressure. So this formula can be used to find the relative molecular mass. So the relative molecular mass is equal to 2 times the vapor pressure, which is equal to 2 times 49.5. So the relative molecular mass is equal to 99. Now, to find the relative molecular mass, as I told you, the relative molecular mass is equal to N times the empirical formula. Now, the relative molecular mass you have already obtained, which is equal to 49. So, it is 49 is equal to N times the empirical formula, which is CH2Cl. So, here you are going to find the molar mass of that empirical formula, which is CH2. You sum up the atomic masses of constituent elements. For that matter, for 99, it will be equal to N, then you multiply by 12 plus 2 plus 35.5, which is equal to 49.5. So 99 is equal to 49.5 N. To find the value of N, you divide it by 49.5 in all sides, so the N is equal to 2. After obtaining the value of N, what's follow now is to determine the molecular formula. And here we are going to use this formula. Molecular formula is equal to N times the empirical formula. So here the empirical formula is CH2Cl, but the N is equal to 2. So the molecular formula is equal to 2, then you multiply by CH2Cl. If you multiply here, because in carbon you have 1, hydrogen you have 2, and the chlorine you have 1. So it will be C2H4Cl2. And for that matter, the molecular formula is C2H4Cl2. So this is the molecular formula. And this is the answer for question Roman 1. Okay, now I'm going to answer the question number 9b Roman 2. As the question says, draw and name the displayed or open structural formula of the possible isomers from the molecular formula determined. As you remember here back, the molecular formula is C2H4Cl2. So what's required here is to draw the opening structure of this compound. So how could you draw the opening structure of the possible isomers? And here we have 2 isomers. The first isomer here is this. The drawing is this one. 1,1 chloroethane. 1,1 chloroethane. And this is the opening structure of 1,1 chloroethane. And the name is 1,1 chloroethane. So this is the opening structure for the first isomer. The open structure for the second isomer is 1,2 dichloroethane. 1,2 dichloroethane. The name is 1,2 dichloroethane. So these are 2 possible isomers as displayed from the molecular formula determined. Now, the second question which I'm going to solve is the question from CSEE Necta 2016. I mean question number 7. So the question number 7 of CSEE Necta 2017. A says, determine the empirical formula of a substance that has the following composition by mass: 49.5% manganese and 50.5% oxygen. So here you have 2 elements, manganese and oxygen. What's required here is the empirical formula. B says, give 1 reason why aluminium is chosen to make each of the following items. The first item is cooking foil. The second item is overhead electric cable. And the third item is window frames. So what's required here is the reason why aluminium is chosen to make these items. I will start to answer the question number 7a. From the table here, we have 2 elements, which is manganese and oxygen. The first thing you need to have is the percentage composition by mass. And here in manganese is 49.5, while in oxygen is 50.5. The relative atomic mass for manganese is 55, but for oxygen is 16. Now you have to divide the percentage composition by mass, you divide by relative atomic mass. So for manganese it will be 49.5 divided by 55, which is equal to 0.9. But for oxygen you will take 50.5, then you divide by 16, which is equal to 3.16. Now you have to divide all of these which you obtain here by smallest ratio. And here in 0.9 and 3.16, 0.9 is a small ratio. Now you take 0.9 for manganese, you take 0.9, then you divide by 0.9, which is equal to 1. Then for oxygen, you take 3.16, then you divide by 0.9, which is equal to 4. Now here in manganese, you obtain 1, but for oxygen, you obtain 4. For that matter, the empirical formula is MnO4, I mean manganese dioxide. Manganese for oxide. Manganese, it's 1, but oxygen is 4. So this is the empirical formula. Now, answer for question number 7b. As the first, Roman 1, 7b Roman 1, aluminium is chosen to make a cooking foil because aluminium is light in weight. The first thing, the aluminium is light in weight. But also the aluminium is strong. Although it's light in weight, but it is strong. But also very low toxic. But also the aluminium fold and wrap close to the food, then stored. If you want to store a food, it can be fold and wrap. So this is the reason why aluminium is chosen for making cooking foil. Roman 2, the aluminium is chosen to make overhead electric cable because it provides a better conductivity. The first thing, it provides the better conductivity. Also, aluminium acts as insulator in case of lighting, and also it is lighter in weight. So this is the reason why aluminium is chosen for making overhead electric cable. Third, aluminium is chosen for making window frame because it is light in weight, resistant to corrosion, very strong, malleable, and easy to work with. So these are reasons why aluminium is chosen to make a window frame.